Hi everyone, it's Mrs. Allman, and I'm going to walk you through, I believe it's lesson 9, session 3, and we're talking about graphing linear equations in the form y equals mx plus b. So this is just an extension of something you've already been doing in class, and we're continuing graphing and just looking at the different points that are on our graph that we've created. So just a quick reminder, with your equation, your number that is with your variable is going to be your slope. So here we have -4 as our slope. And then whatever we're adding or subtracting to our equation is our y-intercept. So here we have it as 8. Again, a quick reminder, slope is always going to be rise over run, or your change in y over x. So basically your y value over your x value when you find it. Lines with a positive slope are going up towards the right, and then lines with a negative slope are going down towards the right. So just keep those in mind as we're working through today's lesson. So here we have a 13-gallon cooler is filled to capacity with ice. Elena opens the stopper to let out the melted ice to drain out of the cooler. The equation y equals -2x plus 13 can be used to find the y, the number of gallons of water left after the cooler drains for x minutes. Graph the equation. So we have our equation y equals -2x plus 13. You guys have been graphing in class, so you should remember that we're starting with our y-intercept, and we write that as an ordered pair. So it's going to be 0, comma, the number that you're adding or subtracting. So in this case, we're adding 13 is my y-intercept. So I'm going to go ahead and plot that. This is my y-axis, which is going vertical up and down. I'm going to put my point at 13. Then I have my slope. My slope in this case is -2. So slope again is rise over run. So I have -2 over 1 because I need to know how many I'm running. So I go to my y-intercept and I'm going to go down 2, 1, 2 to the right 1. And I just continue that, plotting my points. One, 2 to the right 1, down 2, right 1, and down 2, right 1. So I just went until I ran out of room on my graph. That is my graph for y equals -2x plus 13. Just a reminder, my slope is negative, so it's going down towards the right, and that's exactly what my graph is doing. And I have represented my 13-gallon cooler emptying out. So let's take a look a little bit closer at this problem. So there are some other things that we can do with our graph. We could look at our graph that I just created and talk about what are the different points on there. But sometimes we're given a problem and we're not given a graph to look at, and we have to figure out what are some other points on there. So that's where we're starting with the y-intercept and using the slope to find the other points. So we already talked about this problem. That's my cooler problem, that my y-intercept was 0, 13. And I know that my slope was -2 because I was going -2 over 1. -2 is dealing with my y. 1 is doing with my x. So I can use all of that information to help me find other points on my graph. So if I use 0, 13, which is right here, 0 and 13, my y, I am subtracting 2 from it. So that's why I'm doing 13 minus 2. My x, I'm adding 1 to it. So that's why I'm doing 0 plus 1, which gives me a new point, 1, 11. I can continue that, and I can add, again, 1 to my x and subtract 2 from my y, and I'm given another point, 2, 9. Now we need to try that out and see how we can come up with the answer. So I can do 2 plus 1 because that's what my x value is. And then I can do 9 minus 2 because that's what my change in my y's are. So 2 plus 1 is 3. 9 minus 2 is 7. That's another point on my graph. It also wants to know, would 9, -5 be a point on the line? So let's just take a look at another way we can do this instead of just looking at coordinate or ordered pairs. So I'm going to put my latest one, 3 and 7. I know my y's, I'm subtracting 2 from each time, and my x's, I'm adding 1 each time. So if I were to come up with another ordered pair, 3 plus 1 is 4, 7 minus 2 is 5. So that would be another one. Again, I'm just checking to see if 9, -5 is on there. So let's continue this, adding 1, so that becomes 5, subtracting 2, so that becomes 3. Try it again, adding 1 on there, so that becomes 6, subtracting 2, so that becomes 1. adding 1 on there, so that's 7, subtracting 2, so that becomes negative 1. I am out of room, so I'm just going to move it over here to my x, y. So I have my 7, negative 1. Again, I'm adding 1, so that becomes 8, subtracting 2, so that becomes negative 3. And then I need to go one more because I'm getting to my 9 for my x, so add 1, so that's my 9, subtract 2, negative 3 minus 2 gives me negative 5. So is 9, negative 5 a point on the line? Yes, it is. So I did that just by using my slope of subtracting 2 from all my y's and adding 1 to all my x's. So let's continue this because we're going to practice that in just a moment. So going back to this, we have my graph, and this is the graph that I already plotted for you guys of the cooler problem. And we see all those points on there. So I could also have, for that last problem that I just looked at is 9, negative 5 a point, I could also go over 9, down 5 and see, oh yeah, that's a point on there if I had a graph. However, I didn't have a graph on that paper, so I needed to use another strategy for that. So this question, number 1, says, look at the graph. Do all the points on the line make sense for the situation? So just a reminder, our situation is our cooler is emptying. So we want to know how much water is left after X minutes, because that's what's my variable on my x-axis. So would it make sense at 6 minutes, there's 1 gallon left? Yeah, that makes sense. However, if I go to 8, at 8 minutes, there's negative 3 gallons left. Does that make sense? No. So all of these points here do not make sense in the situation. So do all the points on the line make sense for the situation? No. Any y value that's negative doesn't, because that would be negative water, and that does not make sense in context. However, if this was not a context problem, those values that I circled down there would all make sense in this problem. Then it says, look at the analyze it and graph it. Why does it make sense that the slope is negative? Well, we're emptying water. So that is that should be negative because you have water coming out of your total. You're not adding water to your cooler. Why does it make sense that the y-intercept is positive? Well, the y-intercept is your starting amount. So it would make sense to be positive because we have a positive amount of water. So again, we're just looking at context of what makes sense. Then we have another concept thrown at us, and that is horizontal and vertical lines. So if we look at our horizontal and vertical lines, we want to figure out what is the slope and what would the equation be. So explain why a horizontal line, which is pictured right there, has a slope of 0. Well, if just a reminder, your teachers taught you to find slope as you pick 2 points on your line. So here's a point and here's a point. And slope we know is rise over run. So how many would I rise? 0. How many would I run? 1, 2, 3, 4. So if I were to put in my calculator 0 divided by 4, that gives me 0. So that's why my slope would be 0 in this case. What would my equation be? Well, I don't have a slope. It's 0, so I wouldn't have an x in there. I would do y equals, and I cross the y-axis at 2. So y equals 2. It's just basically a y-intercept equation. Now, explain why we use the term undefined to describe the slope of a vertical line. Again, let's pick 2 points. We're doing a rise over run. So I rise 1, 2, 3, and I run 0. If I were to put my calculator, 3 divided by 0, my calculator would tell me this word undefined. So that is why my slope is undefined in this case, because you can't divide a number by 0. What would the equation for that be? Well, it's crossing the x-axis at -2. So my equation would be x equals -2. So when you see those equations, that's what we have. 0 slope would be a y equals, an undefined slope would be an x equals, and that's the reason behind it. Then we have a final question to wrap up today's lesson. We're extending our graphing to just looking at points on coordinate pairs. So point P is located at -1, 5 on the coordinate plane, and point Q is located at 3, -3. Which point lies on the line PQ? So the first thing we want to think back to is that problem that I just had with you guys was starting with our y-intercept and using our slope. Well, in this case, we're not given our y-intercept because none of our values have a 0 in there. So we want to find the slope. So I'm just going to make a quick xy table, and I'm going to put my points in there. -1, 5, 3, -3. I pulled those directly from the problem. And then I just want to find what is the change. So how do I go from 5, -3? I subtract 8. How do I go from -1 to 3? I add 4. So my slope would be -8 over 4, which I can reduce. I can divide both numbers by 4. And I'm left with -2 over 1. That is my slope. But now I want to know A, B, C, or D. Which one of those points also line on the graph? So I could use what I was using earlier, where I just keep using my slope of subtracting 2 from all my y's and adding 1 to all my x's, or I can use a new strategy. You guys learned in your previous classes and sessions that it doesn't matter what points you pick, that you will always be given the same slope based on those points if they lie on the line. So let's just take a look at that. So let's look at choice A. So I'm going to label it with A, and I'm going to use another XY table, and I have -1, 5, and then I'm going to use 5, -13. So rise over run. So I want to see, how do I go from 5 to -13? I subtract 18. How do I go from -1 to 5? I add 6. So that would be -18 over 6, which you can divide both by 6, and you end up with -3. That is not the same slope as my other 2 points. So A is not correct. I can now try B. Again, make my XY table, and I have -1 and 5, and then I'm going to use 2 and 1. How do I go from 5 to 1? I would subtract 4. How do I go from -1 to 2? I would add 3. So I have -4 over 3. That does not reduce down to -2, so B is also not correct. One other option I have is C, which I have my X and Y table again. I am going to start with my -1, 5, which again is just a pair that I have up in the problem, and then I'm going to use 1, 1. How do I go from 5 to 1? Well, I subtract 4. How do I go from -1 to 1? I add 2. So rise is -4, run is +2. That reduces down to -2 over 1. That matches my slope up here. So C would be my answer because I end up with the same slope. This is just another strategy you can use of finding other points on your graph. That's it for today. I hope you have a great day, and we'll see you back at school soon.